This is a swale, and we've earthworked this feature just simply to harvest water in the landscape and soak it in so that it transits through the landscape very slowly. But we've laid up a small area here to ground covers, annual ground covers, and we've planted specific trees in position so that they, like the ground cover, they nurse the establishment of productive trees through to long-term ecosystemic stability. And we're going to start that process with a few students of ours here, Northern New South Wales, the home of the Permaculture Research Institute. And just behind us is a massive green, which is a food forest, which is about 6 years old. And we're going to show you the succession from the very beginning through to a very nice established system where you'll realize how comfortable and pretty and entertaining and productive and also energy efficient these systems are. They're really like the ultimate comfortable habitat of humanity. Right now we're coming into winter, so we've still got a little bit of summer weather left. So we're going to mix up two different types of fast legume cover crops. One will be a cowpea, which is a summer legume, and there's this little fella here. He's actually already coming up and is already starting to play its part, but it'll die pretty fast. This one will die as soon as we get cold weather. They give us a bit of cover and a little bit of insurance. And then this one, this is a lupin, and that's a winter legume, and that'll live till the end of the winter. And this is the time of year when winter's just about to start. So this will be our main ground cover for the 6 months, and we'll put a few more in as well. But they're just the very first recovery crops. And we're going to put a nitrogen fixing bacteria on top of the seed. It's suspended in a peat, and in here are millions of tiny root nodule bacteria, and these little bacteria, they live in association with the roots and they fix atmospheric nitrogen in the soil. They exchange the nitrogen with the plant, so the plant gets a lot of nitrogen feed, but the little bacteria get starch from the plant, sugars, base sugars that the plant just makes from sunlight, the wonder of photosynthesis. Here we go. Come on in. There we go. There's enough in here to do 100 kilos, so that's well and truly enough there of our cowpea inoculant. And then here's our lupin inoculant. Put a bit of that in there. Plenty. That's absolutely plenty. There's gazillions of little organisms just gone into that water. And I mix them up, attach them to the seed. This white seed, or the light coloured seed, is lupin, and the brown seed is cowpea. The cowpea is the summer legume, and the lupin is the winter legume. So we're right on a change of season here. So we're putting two different types in. We'll get a bit of summer growth, and then it will die off as we get cold weather, and then the winter growth will take over and run for the whole winter. And it'll be our nurse crop. And there's our bacteria. See, it's all gone slimy. That's peat with bacteria in it. And there's millions of little organisms in there that are already attaching to the seed. So they'll be in position as soon as they start any kind of germination. They'll be fixing nitrogen in the soil. Alright, so all we have to do now is carefully spread this on the bare soil as our main cover crop. And we're going to go across the whole system and kind of pepper it with seed. So once we've peppered it all with an even coat of seed, then we'll start this sort of complicated but we can explain why. It's a little bit complicated, but it's really interesting combination of species we're going to put together that'll start a natural evolution of forest, but a designer forest, a forest that's really productive. A week later, this is what it starts to look like. The cowpea's up and it's already putting its little holding roots down and starting to fix nitrogen already. And the little feathery plant here, lupin, it's also starting to grow. So there's a stable layer of plants coming up that are going to give us our first sort of cover and stability, and start to sort of exchange elements with the soil as well as protect the soil. So this is the beginnings of the food forest, and the very first sort of action that happens, and it's all going to go quite rampant from here. The next seeds we're going to put in are very fast, short-lived trees that live for just a few years, and they're our secondary cover. They'll be our long-term mulch. We don't have to introduce any mulch after a while. We're going to grow our organic matter on site. We're just manipulating the fast carbon pathways that are quite contentiously called weeds in a lot of places. They're almost like hard-working immigrants in a lot of countries. They come in and do a lot of the groundwork where the locals haven't really got the ability to do it anymore. So these fast-growing plants do a lot of work. They assemble a lot of elements so that a succession can come through, and we can orchestrate that succession to be in our favour in all kinds of productive forms. This is Leucaena, and it's a sort of world famous legume tree of the subtropics and tropics. Grows in the deserts even, and it lives for about 10 to 15 years and will be one of our longer term nitrogen fixing trees. It won't be here at the very end, but it will be here in the mid-term, and it will be chopped and dropped as mulch as an addition to the soil. So it'll be fixing nitrogen and creating mulch, and a medium to long-term shelter for the small fruit trees. So now we're starting to position our main trees. This is a legume called ice cream bean, Inga edulis. And it'll be a long-term legume that lives with the food forest for a very long time as a sort of nurse support species. This particular tree will be a shelter after a few years of the fruit trees. And just below us we've already positioned a rose apple, a subtropical fruit tree, and there'll be other trees positioned. Now these trees, they'll actually get a little bit more special attention. That's what this messy cardboard is for. We're going to cardboard and paper mulch around them and give them an extra bit of straw mulch so they get a really good start in life. These we can't afford to lose, and most of the support species that we plant have these nitrogen fixing nodules on them. There it is. It's a little colony of rhizobium, meaning root, rhizobium bacteria. And when we prune this tree later on, when we cut the top of it for mulch, it'll regrow. But by cutting the top of the tree later on, it'll self-prune its root system and drop bacteria and colonies into the soil, because it won't have the same area of leaves to pump from, and it has to diminish its root system. And when it does that, some of these bacteria, and there'll be millions of them by then, will drop into the soil and feed our fruit trees. And that's exactly how it works in nature, except we're designing it here. We're actually orchestrating the way we want nature to work for us. No chemicals, just natural life processes growing a permanent forest of productive species. So we'll tuck this little South American in here, and we'll give him a bit of mulch later on, and we'll mark him with a stake, because there'll be so many ground cover support species. If we don't mark him with a stake, we won't find him in a few months' time. it'll be in such a blanket of cover crop. No shortage of irrigation on this one. The rain's soaking into the swale mound. The food forest just 3 months old. Multi-species coming into all different layers, and well and truly on its way. And with a passive swale irrigation like this, you really can't fail. Casuarina, an Australian tree that fixes nitrogen like a legume, but it's not a legume, and fixes phosphate with a fungal relationship. So great support tree, and it works well on the back of the swale. Doesn't have to be spoilt on the front. You can go both sides, but doing a great job here. Just 12 weeks old. This little bush is called a Tephrosia. Already starting to flower, and yet it's only 12 weeks old. It's a great legume that can be chopped, dropped, and added down to fruit trees on the swale. Galangal underneath, a culinary herb flavouring. Sweet potato taken over from the annual grand cover cowpea that's dying out now. Comfrey added minerals. There's just a whole association of plants here. So here, looking out over the swale, we can see small tree canopies starting to emerge. Pigeon pea, even sacred basil, different types of cassias, clumping bamboos, fruit trees like rose apple and mulberry. We've got Tephrosia legumes, Schizalobium legumes, Tipuana tipu, ice cream beans. There's mangoes and citrus. All kinds of mixtures are starting to emerge, and the canopies, although it's small, it's full, and it's sheltering the productive trees as they come through to the advanced canopy. It's just so encouraging to see the system nicely locked up and secure even after just 12 weeks. Sweet potato here is starting to form a grand cover. This is a perennial. It doesn't have to be harvested for roots. It can be a permanent grand cover until it gets shaded out by the long-term forest. So we have lots of little legumes coming through. We've got a whole associate of plants as usual, and the swale system here swings around the landscape on contour and turns around the complete ridge actually to the other side. Everything harvesting water passively. Fungi. What an important part of cycling carbon. Here we are. I can pull this back. Here's a whole load of oyster mushrooms. Breaking down a log in the forest, trapping little pools of water. They're actually transferring that wood into soil. This is the teeth of the soil, which is all mouth. And they look pretty soft, but they're actually very sharp because they eat all the wood and turn it into soil. An essential part of forests is understanding that without the fungi, we can't create the forest. A forest grows on a fallen forest, and the fungi are exactly the element we need to turn it into soil. So we're always very pleased when we see different types of expressions of fungi patterns. The more diversity, the better. Beneficial element, fungi. Pretty good food too, a lot of them. So this is a weed system that's just naturally occurred. An assembly of plants that have just appeared from the landscape. This side is kind of a designer weed system. We've mimicked the weeds that occur in nature and their fast carbon pathways. What we put in particular design elements, short-term, long-term, ground cover, tubers, bushes, and we've occupied all the space that would normally be taken by not such friendly weed regimes. We've used the systems of nature, we've used the systems of weed domination in our own design to end up in the future in a very permanent productive forest. So it's not being angry and it's not being prejudiced about the way nature works and how weeds come into the picture, but actually using their strengths, using their functions to get a result that you want. Here we're starting to see a complexity of pattern and form as it emerges out as the young food forest. And when you realize how much work these different trees are doing to actually support the young fruit trees, it's a very beautiful thing to see all this diversity. Interactive diversity is how these systems stay stable and build stability. And that's a very important part of design, the interactivity of diverse multifunctional elements. That's very much a permaculture principle of stability in design. Here we are in a more advanced system. This is just a few years in front, and the ground cover is now quite consistent, mostly sweet potato with arrowroot coming through as chop and drop mulch, and a whole assembly of fruit trees and some longer term legumes that we're cutting for mulch at certain times. Fruits falling off the trees. And it's all looking pretty stable actually. It's quite uniform now. If I just reveal this, I'm going to have quite a lot of citrus pretty soon too as the winter comes on. Quite a lot of mulch plants like this Crotalaria that's good nitrogen fixing legume. There's a few flowers. Just as a distraction of colour distraction for pests, scent distraction for pests. So it's quite a uniform system. If you have a plague of grasshoppers, you have a deficiency of ground birds. Your ground bird habitat is diminished. So in a very blunt and kind of interesting way, you can put turkeys over grasshoppers, and for every 3 kilos of grasshoppers you can get 1 kilo of turkey. So you don't have a grasshopper plague, you have a turkey deficiency. So if you can put up ground bird habitat and a balanced habitat, you won't have a grasshopper problem. Much the same as if you have a snail or slug problem, you have a duck deficiency. And if you don't want to keep ducks, you can have a stumpy-tailed lizard, big fat lizards of Australia that the Aboriginal people in this country call land mullets, because they were also a food source for the native people of Australia. And they eat slugs and snails, and they'll live in your garden or in your food forest very happily. If you have a lot of slugs and snails, they'll bring them into balance, and they just need a pipe or a hollow log in the mulch, and they live for up to 30 years. They're a very long-term element. They'll live longer than your ducks. Well, we're in full chop and drop mode. It's summer in the subtropics, and the growth rate's going really fast. We've got cloud cover, so we've been in rainfall over evaporation for quite a long time, and this is the type of foliage we're cutting, and we're dropping these down. Here's a Feijoa right next to me, a young one, and we're dropping it down as mulch, rough as that. We're cycling the nutrient down on the ground. All this, the forest floor here is built up of branches, and there's all kinds of fungus, little mushrooms, all kinds of little layers. And there's just layer after layer of fungi here actually.
How deep would that mulch go down?
Well, it's kind of etting once you get down to there. I think the soil profiles goes quite a long way, and it's quite enhanced quite a long way down, and it's got that crumb structure. The worm down in there we've dug up. That top layer, see those crumbs? See, it goes like little balls of soil. That's the crumb structure. That's what you're after. See those crumbs? That's what gives you the ultimate structure. That's a sign that there's a lot of life in the soil. All those little tiny balls of soil stuck together, that's all soil organisms. So I had no idea what was under there, but I know it's full of fungi. If I just pull out a branch here, there's all kinds of fungi. Everything's going back down to soil. It's just rotten. 6 months ago it was a tree. We've purposely put it back down to the soil. It's ashes to ashes, dust to dust, and we're manipulating it to an end result of permanent productivity. Over on this side you can see some of these cut legumes have already resprouted, so they're pollarding off and they're starting to grow the new mulch for the next year, so they'll be shaded during the dry season. There's other varieties. This is the Tephrosia, another type of legume. But in amongst us there are also the long-term legumes. So leaning right in here is a Tipuana tipu. It's a long-term legume. It's part of the overstory, and they're actually right up above us, right up around us and above us are Tipuana tipus, giving us shelter and filtered shade, and we're in amongst all sorts of fruit trees at the same time. There's bananas, there's jaboticabas and gramichamas, South American fruit trees. We're underneath a large custard apple here, and everything's running and working like a forest. I can cut these cassia branches here and just throw them down for mulch. I can feed the forest, the fungi in the forest floor, all my organic matters around. I don't need to go anywhere. Everything's on site. It's just a matter of casually manipulating things. I can see a little coffee bush just here, so I can actually cut this ice cream bean back. I can cut a little bit of space, and quite quickly I can mulch around for this coffee bush. In amongst the system we have timber trees that we've particularly chosen that don't affect the fruit trees. In other words, they're non-allelopathic. They have no effect on the fruit trees. They're neutral. So here's quite a high quality silky oak, and this silky oak's only 6 years old, growing in amongst the fruit trees. No bad effects at all. This would be a high quality replacement timber for some of the furniture or window frames in the house later on. There's 4 or 5 of them here dotted through the food forest, and It's a different form of productivity. We've actually pruned it so it grows straight, and it's gone shot out the top of the canopy, and there's no stopping it now. We're going to get a straight bit of silky oak in 25 to 50 years time. It'll probably be milled, or it may go even longer. So if we just chop a section sort of into this cassia, into that cassia, and then let's just have a go at putting it back, see how much mulch we've got. We won't really know until we put it back on the swale. Here we are on a larger outer zone system. We're on a swale again, a main frame swale, and we're a long way from the house, so we're in a less maintained system. The diversity stretched out into the more hardy species. It's less diverse, but it's still a set of layers, and the main species that are represented are the hardy legumes, the hardy climax species, and the hardy fruit trees. A young mango, long-term fruit tree, great fruit. Fantastic timber at the end of its life. The mango. Custard apples. Look at them. Fruit in all on its own. The Annona genus. There's quite a few in the custard apple family, and they're indicating they grow really well on this property. This one's grown all on its own and produced pretty good looking fruit. We can't wait to eat them. Growing in the shade of the Inga and on the top of the mound, an avocado. Needs no introduction. Fantastic fruit tree. Here's the Tipuana tipu, a great overstory legume. If you cut it, it'll regrow, so it's a great mulch tree. Loses all its leaves in the dry spring of the subtropics and puts them all on 10 days later. Fantastic overstory of our climate. Jackfruit. The largest fruit in the world in size, the jackfruit. Fantastic long-term fruit tree. Can live for 800 to 1,000 years. Is a great, beautiful yellow timber at the end of its life. And a good jackfruit is said in India to produce 500 kilos a year of fruit, and an exceptional jackfruit 800 kilos. We have tropical yams climbing up the ice cream bean. Good root yield. And here's another big avocado. 6 years old. This should go on for many years. It's a highly productive tree. It's already fruited twice. And you couldn't really ask for much better than that in 6 years without any effort. Really. Pretty good. This goes for 400 meters. This is 400 meters on contour. It back floods half a meter deep on the maximum rains before it overflows, and it fills 3 dams in the process. So there's 3 main dams on the property that are filled by this swale, and then they back flood up for 400 meters, and all of that water soaks into the landscape. That water then very slowly plumes through the landscape and feeds swales lower down. So this is our main frame and the highest swale for the highest dams. Once we have a mature system, or a system that's close to climax and maturity, it's very, very easy to add on. The hard bit is getting it started. That's why a swale comes in so handy. A swale is self-regulating with the water, so you can get a contour line planted along a swale of food forest, and then downhill from there you can just add on and add on and add on. It's very easy to extend the edge because you already have stability on one side and the water's going down, it's not going up. So you can chase the water down with the forest and it just extends out through the system. So we're now implementing more and more swales downhill from this one major swale. Each one will be forested and be a major division in the property pattern. We're stacking the soil with succession. We're speeding up the succession ourselves. And we can be casual about it and then do it slowly if we haven't got time, or we can speed it up and rev it up and make it all happen a lot quicker and more productively. It's up to us. There's no panic about this. You can do it any way you like. The main thing is that even a vague system like this works. Or you can go to a more intense system and a more diverse system, one with very, very special selected species, and look after it a little bit more, and you'll get a more diverse forest. So right from here at the fungus layer that's pulling in the dead wood, all the way to the canopy, we've got interactions and layers that are all playing their part and being a very special ecosystemic building process. Something that we love to be in amongst, and the wildlife loves to interact with as well. Here we have the beginnings of a food forest, and the chickens were here 2 months ago. And this is the result. There's a fruit tree in the middle of mulberry. It's been a little bit grazed off by some escaping goats, but it survived. If we move across this way, the chickens were here just a month ago. And we've chopped some of the big weeds that have come through for mulch. And we've got a macadamia nut tree in the middle of it. But they were here just 1 month ago, and this is a legume tree just here, and lots of different little features. This will emerge into that. That will eventually emerge into one of those systems. Over 3 years of progression, that system has been planted by the chickens. Now if we move across here now, this is the chickens as they are today, and we're just about to move them. And when we move them, we'll be able to see very carefully and clearly that they've actually really prepared the ground in probably one of the best ways you can prepare ground. They've scratched it all up, they've manured it, they're still scratching, they're scratching away right now. They're pecking out seed, they're pecking out pests, they're manuring and they're shredding the mulch. And we'll move them over and let them get on the next bit of ground, and they'll love it because they'll get on the fresh ground. They live to scratch. We'll then plant this up and we'll continue this progression on. And it's just one simple way of doing a food forest, of starting a food forest. When you include poultry, chickens, ducks, or geese, they have to be timed so that they're introduced when the system's large enough that it can handle their physical presence and their scratching and grazing, turning the surface of the soil and the leaf litter over so it decomposes quicker and feeds the system. But also they're manuring the soil, but also they're breaking pest and weed cycles. So they're breaking pest cycles by eating pest larvae. The fruit fly is a classic. The fruit fly stings the fruit on the tree, and the eggs of the fruit fly are in the fallen fruit when it hits the ground. The larvae pupates in the fallen fruit and then crawls out of the fruit and goes into the ground, where it then carries on its development and hatches later on as a fruit fly and goes back and completes the cycle. The chicken breaks that cycle because any fallen fruit with larvae in it are actually eaten by the chickens. So you can break your fruit fly cycle by including chickens into your system once your trees are large enough to fruit. Now this is sorghum, so we can cut the heads off these to feed the chickens. So we'll cut the heads off the sorghum all the way round, and that'll add to the chicken feed because the chickens did the work to create this system for us. So this is grain that we can use as chicken feed. So there's already a return of surplus. The system's already returned something back to the chickens, although they've left. And they won't be coming back in here, although future generations of chickens might be in here when it's mature. But they won't be in here for a while because it's a young system. It has to be a lot more stable and it has to be older before it can handle chickens again. But they started it, we're giving them some return, and now we're going to chop and drop.
Okay.
That was a lunch bell.
Yeah.
Free lunch bells.
Food. There we go. Pretty quick, eh? From what looked like chaos to what looks like kind of like harmony. We've got a rose apple and we've got a nectarine and we've got a peach and we've got a citrus down there. We've got cycles of organic matter going on. We pulled out a load of food. We fertilized our trees. We reposition the mulch, and we've got our future chop and drop, nitrogen fixing legumes all there. It's not really that complicated. It's interestingly complicated. It's definitely not rocket science. It's just the way nature works, and we're directing the show. We're choosing the instruments in the orchestra, and we're conducting the orchestra. And this is only really this is less than a year old, I think. So this is only the beginning of permanence. And it's the beginning of the concerto really that we're conducting, and it's pretty good fun too. We can all do this, and we can all end up with free surplus food, live food, fresh food, grown where you live. Can be a community park, could be the nature strip, it could be next to the road, could be on the roundabouts, could be all the way through town. All the way through the city, and we hope we can help you do it, because it's not that hard to do, and it works in any climate. It's not just this climate, it's the assembly of function in the form of the species that makes a difference. It's not about this particular plant or that particular plant, it's about the connections between the plants you can grow in your climate. Not a problem. A lot of the weeds here that the chickens, yes, a lot of the weeds the chickens have been scratching through are actually weeds from our garden, and they're returning the minerals that they're harvesting. A lot of weeds are mineral reactions to deficiencies, so they harvest the minerals that are deficient. Well, the germination condition that creates the weed in the first place. The weed is a response. It's a symptom of a cause, and often the cause is a mineral deficiency. So these weeds have a special ability often, not always, but quite often, to replace or repair the conditions. So if there's a mineral deficiency, often the germination of the weeds and the return of the weed body to the soil repairs that deficiency. So weeds often repair the landscape so that it can go and advance through succession.
What about these guys, darling?
It's a process that's going on all the time. The weeds are remineralizing the land. If you burn the landscape, the weeds that come are fire weeds, and their bodies are always high in potassium because the fire depletes the landscape of potassium. Their roots pull it from deep down, bond it up in their bodies, and when they die, they put it back to the surface. And that happens in numerous ways. There are some weeds that only germinate when there's compaction, and they have deep tap roots, and they decompact the soil. So they're physical repair mechanisms. Then there's weeds that have hair roots, big hairnet roots, and they hold the soil together when it's too loose. And they don't germinate when it's compacted, they only germinate when it's overplayed and over loose. There are all these response mechanisms. Weeds really are they cauterize the wound of damage. That's what they really do. So all this mulch is a real concentration of the minerals that are deficient on this land. We also intentionally mineralize the land through our animal manure, so we make sure our animals are nice and healthy and feed them minerals every day, so their manure is something that produces soluble, plant soluble minerals. So we're aiming to remineralize all the time, and stacking up a system like this quickly with high quality mulch and a succession of plants brings us into a system like that within 2 or 3 years, 4 years maybe maximum, and in 10 years is completely stable. In 10 years time, this will nearly be dark with nothing but leaves on the ground, and it will literally be a forest by function, but a food forest by production. Food forests aren't about how much production you get per tree. That's trophy hunter mentality. Food forests are about a minimum amount of work going in for the maximum amount of product coming out. And the only way you can get that is with diversity and interactive diversity. So you can do very little work to get a really fair volume of diverse product. And because it's diverse, it's production all the time. At the moment, feijoas and guavas are falling off the trees. Pretty soon it will be citrus. When a system's established, the input of work is very small. You can walk away from an established food forest and leave it for 10 years and come back and get half a hectare maintained in one day with one man with a sharp knife or a machete. It's that simple. If you want it to be more productive, you can work it up a little bit. You can tickle it up a bit with maintenance. You'll put a little bit more work in, you get a little bit more production out. But your efficiency of input over output is much higher than monocultural orchards and monocultural agriculture, which is really, it's not a sustainable thing. This is ecosystemic production. It produces soil. Good quality soil with lots of organic matter and lots of life. It smells good. It smells earthy. It's got lots of organic matter inputs. It's an ecosystemic soil. It's built by an ecosystemic process. But this is not an ecosystem that you would ever see in nature. It's not an assembly of species that ever occurs naturally. It's a human designed, a human orchestrated ecosystem. This is the permanent sustainable habitat of mankind. This is the system, which is one of the major systems that allow us to inhabit this earth forever. Well, here we are in the projects and the farm's nursery. Almost everything gets germinated in here, from vegetables and herbs through to nearly all the trees that we produce. We might just buy in some specialty fruit trees at times. All the support species are propagated here, and most of the fruit trees. We're bringing in seed, and we're collecting our own seed. We're bringing in new seed from outside. We find trees that we think have good potential, and we bring in the seed and we grow them on and trial them. And then we're actually growing our own seed as time goes on, and they're actually more and more speciated to be adapted to this site. So we have special seeds that they're actually more than local. They're actually residential. They're residential heritage seeds of this site, and they're very strong. And that's a formula we'll continue to teach on for people, to adapt your seeds to exactly your site. You really do get strong genetics then. This is our potting mix that we buy in for our nursery. We could make it, but it would be a lot of work. This is an registered organic potting mix, so we're trying to stay true to the ethics all the way as completely organic. And this is our main mix that we blend up with sharp sands, river sands. After they've been in the polytunnel, they come into this shaded area to be potted on, and then they go into the sunny area to grow out. So this is their intermediate stage. They move through this area after potting on into the sun, and then onto the ground, in permanent positions hopefully. Well, welcome to the ultimate health food shop. There's I couldn't even start to explain the amount of plants and interactions that are going on in the kitchen garden. There's about 400 vegetables and herbs in here, and fruit trees around the edges, and it's just endlessly producing a massive variety of fresh and medicinal and mineral rich products, and it's got a very large component of actual therapy as well. The psychological effect of working in a system like this, and then knowing that it's there and you've always got those supply lines of food and minerals and medicinals and herbs and scents and just the whole thing about working in here and being in so much beautiful colours and shapes. And it's also part of a cleaning system. Our grey water comes under the lower beds. It's actually cleaning some of our waste products even. Some of our storm water comes through the banana circle and keeps areas damp. It's all designed on contour. It's non-dig. Endlessly enriching soil. Double row reach beds. I think everybody should have one, really. Everyone should have a variation of one of these. It's a place we like to be and like to work, and it's our main food supply. With these beds, garden beds designed so you can reach from one side into the middle and from the other side into the middle. It's a double reach garden bed. You never have to walk on there, you never compact it. That means if you do the right introductions of mulch and compost and worm castings and organic compost teas and things like that, you don't compact the soil, you don't have to dig the soil. You can forget about digging once you set it up. And that means all those little organisms that are in there, all those little things that are working for you, they don't get crushed by your heavy weight. They don't get compacted. The pH, the acid alkaline balance stays nice and balanced, and it's full of life, and it just keeps producing and producing and producing. You can endlessly crop. You don't have to rest the garden. You can just keep cropping and cropping and cropping, and it gets more and more fertile and richer in minerals. And that just brings you up as a healthy, vital person that's continuously eating fresh, diverse, enzymatically rich food. That's what it's all about, getting people to understand this stuff. It's great. And that's the food forest is just a larger extension of that system, that's all. A forested system of this, really. So many colours, so many shapes, so many forms in the garden. The pests are confused. They can't see the most people can't see the vegetables actually, but most the pests, they can't see the vegetables, they can't see the herbs, they're confused. There's different smells in the garden, different aromatic herbs, different colours, different forms, different patterns. And there's lots of perches for birds, there's lots of little frog ponds for frogs, there's lots of little rockeries for lizards. They're all your predators, and they're favoured, and the pests are confused. The confused pests in a garden that looks like this, with predator habitat enhanced, is predated on, it's eaten. So you don't have pest problems. Those aren't something we have to worry about at all. And that's why it looks the way it looks. And it's part of the integrated pest management of design. It's quite simple and it's very beautiful. We're now on Tagari Farm. This was the home of the Permaculture Institute, and when I was the manager here, we planted these trees. I planted this citrus, I planted this jackfruit, and we planted this food forest. And in 2001, we walked away from this system and just let it develop all on its own. Probably some shots in here we definitely don't want to show anybody.
Why not?
It's just to understand this degree of rampancy takes a little bit of special education, I think. This is biomass stacking at the most extreme. This is very, very fast track succession. It's ecology moving at breakneck speed. It really is. I started planting this garden, this forest. It was just all grass, and because it was a small area, it was hard to keep the grass out. And then 7 years ago, it must be nearly 7 years now, we left this to just develop on its own, and it's now that little crescent is completely a forest all to itself. So that's what I'd like to just go and get inside of and have a look at, because I always enjoy having a look at this one. As we worked so hard, we thought we were battling the weeds, and didn't have it tidy enough. It was in front of everybody because this is the main arrival area. Here we are in a food forest that's about 9 years old, and we've got a complete overstory here. There's been no maintenance for at least 7 years. We're actually right underneath the jackfruit. There's a small jackfruit tree here. Just over here we have chocolate pudding fruit, another citrus. There's quite a lot of coffee in the understory. It's regulating itself exactly like a forest. It's maintaining itself like a natural forest. There's quite a few loquats. In fact, there's such a tangle of vegetation, it's actually quite hard to get a good idea of how much there is in here. There's bamboo on the edges. There's a continuous noise of frogs and water flowing because there's a small canal trickling past. All things that were designed into the original system. But this is a classic example of how food forests continue to function even without any maintenance years and years and years after anybody's touched them. So it's very reassuring that these systems will just keep running on their own. You could come in here with just a little bit of manual labour and a few hand tools and get this completely maintained in just a day or two with 1 or 2 people. You wouldn't have anything left to do. And in doing that, you'd cycle organic matter around, open up a little bit of sunlight, and the trees you want to go into more production, you can aim the sunlight towards them. You can aim the mulch towards the productive trees. This jackfruit here could be opened up so that it just sees a little bit more light, and in doing so, what we cut, we can aim mulch towards it, and it'll boom and it'll fruit. So it'll fruit a lot quicker and a lot better. We can untangle the citrus a little bit in the understory. I can now see a Brazil cherry underneath the bananas. The longer you stay here, the more you can see, actually. All of this was 7 years ago. All of this was grass, and there's custard apples and loquats and citrus and rose apple and hoop pine and coffee and mulberry and white sapote, macadamia, some native trees, silky oak and casuarina, all mixed up, and it's just mostly just leaves on the ground, and there's even fruit trees germinating in the understory here. They won't get up to the light, but if there is ever a hole in the light, if there's ever a hole in the canopy, it's probably just going to get filled by a fruit tree, I think. I don't think you're going to stop it. It wouldn't. You can't stop this being a forest. It will go on for a long time. It's our testament as designers, really, that we can produce high quality soil, very stable ecosystemic forests that will produce indefinitely. It should encourage people that we can inhabit the earth forever, really, with very little effort and an ongoing systems that are permanent. We can be very confident that the future can look extremely bright, healthy and productive, and with quite a lot of time on our hands. This is an unmaintained system for 7 years. With a little tiny bit of work, it could be a bit more productive. It couldn't be a lot nicer to be in, actually. It is a forest. It's a Garden of Eden, really. It's exactly a Garden of Eden. What more could you want?